So Swati, you checked with your the updated script that I updated there.
Yes. Yes, ma'am. The updated script is working well.
Okay. Yeah. So what happened is actually like when we were working with 3PLM script, so what I tried was without normalizing the data. So here in this step, like where we are performing normalization. So what we did is we saved, right now we are saving our biophysical features in the same variable, which is already defined for biophysical features. So whenever we are scaling or normalizing our data, so that normalized data is saved into again biophysical features, which is the default feature that we are using everywhere. Uh, Otherwise, the script that was not generating the model, the normalized model. So what happened was we were using scaled features. So after bio features, we used underscore scaled. So that was different, like making the normalized data stored in different variable, which we are not using any further to make the model, the final model that we are making. So that was the one thing which was different in this this script, where we are normalizing the data and then saving into the same variable. Otherwise, what we can also do is, if we are renaming it that this is our normalized data, or even if we are making it name as scaled data, or like it is scaled only. So if we are mentioning normalized or scaled data, then we need to use the same variable everywhere. Like here, if we are now making data frame, so if we are normalizing data but we are using old variable for making data frame, so that will not considered into account while developing the model. So that was the one issue, and the model that was generated in 3PLM was not with the normalized biophysical features, but the default features which we were taking from other the computation values that we got while evaluating the biophysical features. So that was the one thing. The data was not normalized, that I got to know after
Yes.
checking or comparing the two models.
Ma'am, and also that charge, that graph, this one I don't understand this.
Yeah.
Yeah.
So this is the charge, like if we want to check that what are the top 5 positive charges, like which sequences have maximum positive charge and which sequences have maximum negative charge, so that we have visualized. We can also save this one into CSV file, so that if later we want to check that how the charges are changing based on the sequences.
And
Because
this PH 7.4, is there that any
so
standard
pH,
for?
yeah, standard scale, which is a neutral scale. So whatever is
Scale.
above this and below this. So no, this is about
7 is
the, yeah,
the.
standard maximum scale for the charges, which is
Okay,
given
okay,
for the
okay.
all the sequences.
Mhm.
So after that, if if it is positive, so that will be among the positively charged sequences. So this is not exactly for any like amino acid or something. It is average of the whole sequence, like all the amino
Okay.
acid sequences whichever
Hmm.
are there. So this is based on that, and based on that we can generate different type of figures, so that can be helpful to add in the publications. And this is the bar plot, where we are not able to see the, this is just the like we have rotated the x-axis to on y-axis and y to x-axis, and here we
Okay.
are not able to see the sequence IDs, because it was like we had 158 total
One. Hmm.
sequences. So it was kind of mess here. So we can just name it sequence ID, and it is just in the order that based on whichever sequence has highest charge, then it is on the
Mhm.
top, and lowest charge is on the bottom. So these type
Okay,
of
got
plots are quite good when we are adding in publication, so that you can use. So for
it.
each type of data set that can be generated. And then other figures we already have. And yeah, so 45 we got the results for contrastive loss and the positive negative pairs. So positive negative pairs we are getting same from all the models, because most probably they are trained on the similar type of data set, and mostly on UNIREF 50. So that's why, or whatever the sequences that we have, they all are included in these models which we are already using. So that's why we are getting the same number of positive and negative pairs. And these distances are more reasonable than the one that we were getting. And for that, because we were getting very large difference, some sequences have, like, for some sequences there was one or two charge distance, but for other sequences there was 600 or 6000 distance. So that's what, like, then only I got to know that data seems not normalized. Otherwise, when we normalize the data, so the range varies between a certain scale. So it should not go beyond 0 to 1 if the scale we are setting 0 to 1. Otherwise, it should not go beyond 0 to 100. So never above 100. So like that, if there is this type of imbalanced data where variation is a lot much, we should naturally understand the data is not normalized, or the scale before developing the or designing the model that we generated with the customized model using the already trained model. Okay, so this is just one type of, like, graph we can use, but this is not that much reasonable, as we can see a lot of sequences we have to compare. So if we want to just use like top five sequences which are positively charged, and bottom five sequences which are negatively charged, we can make that type of graph also, like include only those sequences. Then it will look more meaningful rather than this one. This is just one way to see that how your sequences are connected with each other.
So we are comparing, for example, sequence 1 with all
Yeah.
remaining 157 sequences, then sequence 2
Yes.
with remaining 157.
Yes, so sequence zero, like sequence zero is sequence one. So this is connected to sequence one, and then all the sequences, then depending on the distance, it will be showing like different color for the what is it a positive pair or negative pair? Depending on that, the edges are colored here. Okay, so
Okay,
if it
so
is positive, then this is sky blue, otherwise different. So
so
for
how can
nodes,
we make changes for only 5 most positive and 5 most negative?
so for that, when we are generating the filter of our charges, in this step only, we need to save those sequences which are top five positive charges. So these sequence IDs we need to extract here and then make a function for it, so that we can save these sequences only, and depending on these sequences we can make a group of them to make the cluster later after that. So that we can write code separately for it. I
Hmm.
will update this one later, because
Okay.
right now this is not connected to my drive right now, so it will not work as of now. Okay, so this is
Yeah,
like pre-executed script, no? So that's why. Otherwise, I need to load the whole data set and then model.
right.
Okay. So maybe I will upload this one with the code, so you can check first in this section for the chart section. After
Hmm.
plot, or either after this, I can add another code chunk so that we will have the
Yes, ma'am.
so here I will add, and top
Hmm.
5 and
And this time we have used that arc large model. Last time we have used small model.
yes, right. So yeah. So yeah, so these two we need to extract and save in variable. So once the positive and negative pairs are like estimated, then we can use the variable to extract to generate the figure for the network figure for that. And we can also do that, we can use these sequences like get top 5 or top 10 sequences from here which are showing very less distance between them, and then we can make the network figure for. So there is different ways, depends on us that how we want to visualize the figures and how it will be more relatable for us. Okay, so that
Yes.
will totally depend on us. And then yeah, so this correlation plot is
Hmm.
again showing the same relation that we were seeing in the text format in this section.
Hmm.
So the same thing we are seeing here. This is a long
Yes.
list actually. So here we can relate. So you can just make this figure smaller because this is too
Hmm.
big to add in the manuscript. And then sequence IDs will again, we need to remove because it will be quite mess if we are adding all 158 in a small figure. So it is
Hmm.
just to understand that how the sequence are
Hmm.
related, and based on the color intensity or similarity score that is given here on the scale, we can see that
Yes.
how the sequences are like related to each other, and how different they are related to each other. So that is like kind of useful plot. That,
Here, in this diagram also, can we make for only five most positive and negative?
yeah, 5 most positively. So that will be depending on charge only. But
Hmm.
why we are focusing on only charge? We can only focus. We can also focus on molecular weight or
Yeah,
even the
other
other
parameters.
physical
Hmm.
features, right? So
Yes.
rather, what we can do, we can make for top 5 or top 10 sequences which are showing the least distance between them.
Hmm.
So that can
Yes.
also be possible. Okay, otherwise we can make different ways, like totally depend on us however we want. So I will try to add for based on charge also, or for molecular weight, like for all the biophysical features, so that we are having a couple of figures to demonstrate the
Hmm.
results that we are having in hand. Okay,
Hmm. So we can justify that why
yeah,
those
right. So
features are considered.
difference. Yes, and also when we are comparing the results between different models, like the PLM models that we have used, then also these type of figures will be very useful to compare the
Yes.
results. So that also I tried actually making it in the plot, but like here I try to generate all the this contrastive loss figures that we generated,
Hmm.
and we so that we can compare the loss graph. So this way we
Hmm.
can also compare for other figures. So that will be useful
Okay.
for us when we are comparing the loss for us. So we will check this later. Maybe I will add more figures to it here so that we can understand that how the difference is varying for different models. And
So
yeah,
also here that epoch, what does it indicate? Actually, as per my knowledge, we repetitively perform the steps.
so for each epoch, so it is, yeah, it is trying to read your data or the whatever embeddings we have in the model. It is trying
Hmm.
to go on the data like 10 times. So first times it will go and try to learn the pattern from that, so the model
So
that we
it
have.
is so number of iteration for training like that it
Yes,
is there, right?
yes, right. So
And
and right now we are having the loss. So for each
huh,
training, what is the loss percentage or the probability? Then that's what it is showing here. So for each training phase, what is the estimated loss? Like what should be the real one, and what is like exactly calculated by your law like loss estimation that we done while contrastive learning, what the model has learned already, and what should be the actual one, so that this is trying to calculate the difference between them. So that's why it is showing the difference. So it is in terms of loss, like what should be the actual and what actually has been learned by the model. Whatever is the difference is showing in terms of loss here. So every time, so we can also like increase the number of epoch values, and we can see that how actually it works over the epoch values. Like maybe after 15 or 20, it is going like straight onwards, or like totally going downwards. So like very less loss, right? So we can say that after 10, like after 10 epoch, it is showing a stable loss. And at that time we can say the model is like stable now, and we can consider that the model as a finalized model. Otherwise, right now we can see there is a lot of variation in the loss, but this variation is too less to consider to for hyperparameter tuning for the model that we are having. Otherwise, if the loss was more, then we need to consider to hypertune our model. The model that we generated with prod K5, or this is I think for prod T5, or even prod BERT. So this is what loss tells us. If loss is too high, for example, let me show you here, I think in the next figure. So this is for prod T5, I guess, the first one. That's what it is showing. And we can see here, as we have the observation that curve is fluctuating, and lowest loss is around epoch 1 and epoch 5, and then we have the highest as epoch 2 and epoch 10. Okay, but the range is since 0 point like 2 minimum for us to consider as a big loss for a model, because we have standard values, the decimal, but the loss is going like from the 4 digit counting. So this is like this can be considered, or we can also consider to again tune the model first, because the loss is very big.
Ma'am,
Uh,
your voice is breaking.
okay. So not visible, not audible.
Yes, now it is clear. For
Okay.
previous statement, it was breaking. I learned that if the range of loss, if it appears very large, then we need to hypertune the model. That much I learned.
Yes, right. If loss is more, but right now we can see that from standard 3 digit, we have the loss at the 4 digit values. So we can consider the model as a fine model, and we can proceed with it. Otherwise, we can that totally depend on us, that how much precision we need for our models. Okay, so if we are getting other models more like more number of more loss there, so we can keep this model as like a stable model, and then hypertune the other models. Okay, so
Okay.
let's see in the other figures what we can see here. And this code I have commented out, because this is to show the pair for each sequence, what is the positive pair and negative pair similarities. So this will show us line by line, but since we have a lot of sequences, 158 total sequences, it is showing like the whole details. So this we don't need as of now, but if we want this output, so you can just uncomment this and run this chunk again. So it will show you
Okay.
all the loss, positive and negative pairs, and with the loss. Okay, right now
Okay.
here we have all the 10 epoch values, and you remember in the last session we saw that all the epoch values were same, like 4.815. So at that time, we were looking at the 3 decimal points
Hmm.
here as 3 float values. So 3F stands
Okay.
for 3 float values. So I try to make it more values so that
Hmm.
we can see the variation. And now we can see
Hmm.
with the 9 values that there is variation, right?
Yes, yes.
After 4 to 5 digits. So now
Hmm.
we can know that there is loss, but it is
Hmm.
very minimal. So we
Hmm.
can
Hmm.
consider the model as a fine model for us for prot5, and for protbird we can similarly check and compare the results. So the pairs are same
Hmm.
that we have for positive pairs and negative pairs, and the distance are somewhat similar. I have not compared this one. This figure is irrelevant right now for us, but we can make it precise to make some meaning out of it. And then here the threshold value, it will change again depending on the threshold value it is keeping for all the sequences. So right now it is 21.1 based on the positive pairs and negative pairs it is calculating for
Hmm.
us. And here we can see in this one we are having the contrastive loss, like variation is more, and at the 10 epoch the loss is more here. But
Hmm.
again we are having the loss with 4 point like this
Exponent.
number
Hmm. Hmm.
multiply by this number, like 4.824 into 1 to the power 10 to the power minus 5.
Hmm.
So that is
Right.
again too less for us
Hmm. Hmm.
to consider to our model to be unstable.
Right.
So that's why we can keep is as a fine because the loss is extremely small, and
Hmm.
we can consider it a fine model to go through. Okay.
Yes.
Um, and yeah, so again, the lines are commented out. This is
Hmm.
unnecessary information. And we have the epoch values almost similar to the
Hmm.
other model.
P5.
So this is for like CASP 10. And for
Hmm.
the other models, I will update in the drive
Hmm.
today,
Hmm.
so that
Okay.
you can also execute there and it
Yes.
will go together. And here we have calculated the distance with the 4 digit.
Hmm.
Like we have
Hmm.
added 4F, we can make it
Hmm.
more to see if
Hmm.
how the distance are varying. Okay, if
Yes.
required. Otherwise, we can. And if you want to save, you can also keep the data saved so that
Hmm.
anytime if the script is not running, like without internet or something, we have the data
Hmm.
saved
Hmm.
files.
Yes. Hmm.
So that is a good practice to keep the data with us
Yes.
always. And this is again a visualization part. So we'll go to the meaningful one. Here the threshold is set as 25 rather
Hmm.
than 21, which was in the earlier figure. So you see that the model, depending on the PLM, whatever we
Hmm.
have choose. So this is for AND
Hmm.
model. So whatever we
Correct.
have choose, the variation is there,
Hmm.
right? So now we have
Hmm.
threshold, and it is checking for positive and negative pairs
Hmm.
differently. But at the
Okay.
end, like it is calculating the same number of positive pairs and negative pairs, because that
Hmm.
is
Hmm.
what in our data is same. So that's why we
Hmm.
are getting the same result, because these
Same result.
models are covering the whole sequences that we have in our data right now. So
Hmm.
if
Hmm.
any sequence was not there, for example, in ANT model, some of our
Hmm.
sequences was not there. So then
Hmm.
in that case, we might have got different number of positive pairs and negative pairs.
Hmm.
But maybe let's say in other CASP data, maybe there is possibility that
Hmm.
we are getting different pairs, and in that we can have a discussion for that.
Hmm.
And here again, we have the contrastive loss variation. A lot of variation is there, but we have the exponential power
Short range. Hmm.
here. So this plot like is what it is calculating is what is the actual loss and minus the value that we are having here as the constant value. It is adding to the plot to make it like to show it on a scale, like particular scale. So that's why because we are using the matplot library to generate these figures. So that's why, so it is trying to make the scale so scalable or representable, so that your whole loss can be compact into this particular scale. So again, this scale is less for us, so we can consider this. Otherwise we can also try to hypertune it. Okay, but we don't see like reason for hypertuning as of now,
Okay.
so we can keep the model as it is for this data set, I guess. And then we have the epoch value. So you can also try with the more number of epochs and see how the loss is varying, the contrastive loss is varying, so that accordingly we can like understand that how these variations are like making effect in the next step of analysis.
Okay, ma'am.
Yeah, and for ESM also we have, and ESM2 we have executed. So for that we need to yeah. So this is for ESM1, and again we have a smaller variation, fluctuating, but could be done fine. Could be done like with fine tuning, but that not that much required. If need, if we have time and if we want to experiment with the other values, then we can do. So yeah, so this is for ESM1, and then for ESM2 we need to install from Hugging Face. We have hfexit. So first you can try to install with just pip install hfexit, but if it is not installing, then we can use Hugging Face as the base to install the this package hfexit, so that we can run ESM2. And here we need to remember that maximum length we need to give as 1024, and because this model is having the one, I think 1028 layers, but we need to declare maximum length as 1024, because for the sequences that we have in CASP10, we have the minimum value that we can take as 1024, and for all the models we have taken 1024. So to keep it constant over the models, we are fixing this value.
Yes.
Okay. Yeah. So depending on the layers, there is different versions of ESM2. So remember this one to for the maximum length that we have, because last time I mentioned in the session that that one was having the 2048, so like double this length. When I
Yes.
was using that, it was not generating proper results. Like there was variation and not able to estimate this data because it was having a lot, like very longer length, twice the length that we are already have. We need for embedding to, so that's why we need to be mindful while giving the maximum length. And by default, you will not get in the code for maximum length. So we need to add it here additionally, remembering the length, sequence length that we are having, or the number of
Yes.
sequences that we are having. So for ESM2 also, okay. Here the threshold is 23.63. So it is keeping less than ESM1, I guess, where we had the threshold 25 point something. So, but again, the loss pairs we are having here is considerable, and we can see the loss is constant at 5 6, and not there is not much variation again here also. Even the scale is not much variable, so that is fine. But Prodbird, like out of all, Prodbird is offering better contrastive loss behavior, like when we compare all the figures than the others one. But still, if we are not comparing, then all the losses are fine for all type of models that we have used.
Hmm.
So totally nothing to care about or worry
Yes,
about add for this particular data set.
madam. And what logic they are using to find the threshold value?
Uh, Threshold value for
Positive and negative
yeah, for the
pairs.
positive and negatives. So threshold value is depending on the model that we are using. So how it is able to like define the positive pairs, or like depending on the model, if it is considering 30, like we have defined here in 30, or like 30 percentile that we mentioned, that 30 percentile of the sequences will go into positive pairs, and then more than 30 percentile distance is there between the sequences, then they will go into the positive pairs. So based on that only, the model is trying to estimate the positive and negative pairs, and adding the threshold value for it. So yeah, depending on the yeah, percentile only, 30 percentile and
Hmm.
70 percentile of the data. And, yeah, so this is about Caspen. And for other sequences, we need to perform the same. So what we can do, we just need to change like change your folder, and
Hmm.
then okay, so I think my internet is not connected. So Google Drive is not mounted right now, but what we need to do
Hmm.
is just change your folder name. Like
Hmm.
I'm working here, so you can make it CASP 11 and
11. Hmm.
just change your data set and try to execute the same script in different code. Otherwise, the results will be overwritten for each model.
Hmm. Correct.
And then and I will also update the results in the drive for all the
Hmm.
models up to this
Hmm.
step,
Okay.
and then we can proceed for the next module.
Hmm.
So for that, yeah, so criteria for evaluation for this losses, as we mentioned, that
Hmm.
lower loss is better.
Hmm.
So that's normal, right? So and
Hmm.
the less the fluctuation is, better the results. Like as we see in this one,
Hmm.
like the figures that we are already having from Colbert and Ank model.
Hmm.
But still again, just fluctuation and this average loss we cannot see. We need to also see on the scale what is the
Hmm.
scale value. Then accordingly we can mention that how, if the scale are nearly similar to each other, or and having larger differences, then we can see what is different. But right now scale is so small that
Hmm.
loss difference is not considerable right now for us. So maybe if we are having other data set, we can check on that, that how the variation is happening and the loss we are getting for that.
Yes, ma'am.
So I think that will help. And next is okay. So I think that this is clear for you right now.
Yes, ma'am.
And yeah, so if there is any other query, let me know. Otherwise, we can proceed for next model.
So now we are going to uh, give all this data
Just
as an input to the uh,
um, future statements.
transformer, right? For Q3 prediction.
Okay, just a minute. I'm checking
Uh,
something. There is a data. Yeah, for now, yeah. So once we are done with the like contrastive learning and the
Hmm.
positive negative pairs we have calculated the losses. Now we
Hmm.
have to implement the CAT model implementation we need to do. So
Hmm.
transformer use this data for transformer encoding, and
Hmm.
then we have to train with Q3 and optimize the models accordingly, because right now we are not, we need not to be concerned about the differences or the variation we are getting at this point,
Hmm.
but in the next point we need to be more careful about like what differences we are getting at each step.
Yes. So in next module we will get means how we will going to represent the results, the classification results.
So first we need to perform transformer encoding,
Hmm.
and
Yeah.
then need to estimate the Q3 values.
Hmm.
Once it is done, then we will train the model again with the values that we are getting or estimating.
Okay.
And for after training the model again, then we will try to evaluate the performance of each model. So for evaluation, we can use, for example, if we are training the model on CASP 10, then we can
Hmm.
use the CASP 11 or even for UniRef data to evaluate the model, that whether our model is working better on just CASP 10, or it can work on other data types as well. That is like
Hmm.
sequence data only, but different data
Hmm.
set.
Okay. So trained using one set and testing using another data set.
Yes, right. Training, yeah.
Okay, ma'am. Got it.
So that will be better, I guess, because evaluation is important unless
Yes, ma'am.
we are developing the model.
Because for final justification, we need that
Yes,
Q3
right.
percentage accuracy.
Right. So we can try to evaluate against all the other data set that we are having, and we can record the percentage of what percentage is its like prediction percentage, how it is predicting, and
Hmm.
what is its efficiency.
Yes, ma'am.
Yeah, so that we can do, and I think that will be the like major module for us, because there
Hmm.
we need to be very careful about what results we are getting, because that will be the
Hmm.
deciding factor of the
Yes, ma'am.
project.
Yes,
Yeah, so model comparison we can do based on literature survey. We can
ma'am.
also compare like whatever we are getting, whether it is matching with the literature that is already published there,
Hmm.
and how better, or if it is doing less better than them, like we are
Hmm.
not getting that much accuracy, then we need to hyper tune the models again to at
Hmm.
least get into that range.
Yes.
Mm. Okay. So I
Yes,
think
ma'am.
if you have any other query, or so you got that like you have the link for the other data set, that one
Hmm.
data set was there, right? CB513 or something.
Hmm.
So
Actually, I downloaded it from Kaggle.
okay, from
The
Kaggle. So it
URL
is a
is
raw
not.
data. It is
Yeah,
a
it
raw
is
data.
just. The data set is the number of sequences are also less, and in first column the amino acid sequence, second column each sequence how where they are located in which of the three structure, and
Okay.
in third column each amino acid the out of eight structures where it is located, so that is the data set.
Okay.
Shall I upload that in one folder in
Yeah, you can
by
upload,
my
and
name? Huh.
also maybe where in the dataset notebook that you have shared
Hmm.
in the drive, there you can add one code chunk and add it there. Okay. So I think that will
Okay.
be better for, because
Mm-hmm.
I need the link to at least go through the uh,
Uh,
link
ac-
where it is stored
uh,
exactly.
yes. I will do one thing.
Or you can just share me
Mm,
in chat here right now in the meeting. I,
okay.
if it is there.
Hmm. Can we send attachment in chat? That option is not there.
Attachment, I'm not sure. But if it is
Hmm.
attachment, then just upload in your like code folder. I
Hmm.
will go through it. Rename it as five, the dataset ID, CB513, whatever it is,
Hmm.
and then I will go through it. Okay. And if you have
Hmm.
link, then share in like
Um,
maybe in the drive.
Actually, I downloaded it from Kaggle, but not saved the link. So when I
Okay.
tried to search again,
Mm-hmm.
I not able to find it.
Okay. Okay, no problem. You just upload in your folder, the code folder
Hmm.
that we are having right now.
Okay.
Uh, your folder, and then you have code directory, right? So within
Hmm.
code directory, with your name, you can
Hmm.
upload it there.
Yes, ma'am. Okay.
And I will try to search and
Hmm.
explore it, so that we need to
Hmm.
know that if it is raw data, then we can process, because right now we are executing with faster files, right?
Yes, ma'am.
So I will try to get FASTA if any way it is possible.
Hmm.
Otherwise, we will try to like extract just the sequences from there with some header and like blank header, and then we'll try to execute. Let me see first what is the data exactly. Then accordingly, we'll explore it. Okay.
Okay, ma'am. Code in code directory. In under my folder.
No, in your name, like no,
Huh.
in our share in code directory, there is your name folder, right?
Correct. Correct.
Yeah. So within that, you can share.
Yes, ma'am. I'm just yes. Ah, yes. It started to upload. Uh, the folder name is CB513, and in that folder there are six Excel sheets.
Okay.
Dot CSV files. Dot CSV files.
Mm-hmm. Okay.
So, are you able to see those?
See the added file. So why six Excel sheets are there?
Dot CSV files. So in that CSV file, first column is amino acid sequence.
Okay.
Actually, the from on Kaggle when I downloaded,
Mm-hmm.
uh, so one file is used for training and other files are
Okay.
used for testing. So
Mm-hmm.
accordingly, names are also given:
Okay. Okay. I got it. Okay.
training,
So
testing,
probably
validation,
they have
like that.
already sorted the data and then
Mm.
like separated it into training
Maybe
and
they have used the supervised learning method. We are
okay.
using unsupervised.
Okay. Mhm. Okay. No problem. Okay, I will go through,
Hmm.
and then accordingly we'll see how. If we are getting raw data, that will be fine. Otherwise, we are already having the sequences. So what I will
Hmm.
do is, because they have separated into training and test set, so we'll try to include all of them into one file to make a
Hmm.
FASTA file with all the sequences that are there.
Yes.
Okay, because if it is in Kaggle, so most probably
Hmm.
it is a kind of processed or prepared file. So
Maybe.
we need to go with the raw file.
Right.
Okay, okay, so I will update you
Hmm.
as
Yes, ma'am.
I am like processing the data.
Okay,
Then
ma'am.
you will know how to make the faster file if
Mm,
we are not having like the raw
mm,
file in front.
mm. Yes, ma'am.
Okay. Yeah, okay, sure. So we'll try to proceed with the next model, right?
Yes, ma'am.
Protein. So Q3 only we need to like consider, or Q5 we can try.
Uh, there is Q3 and Q8.
Q8, yeah. Sorry.
Hmm.
So Q8
Mm,
also we shall try.
mm. We can decide afterwards based on the results,
Okay, yeah. So
because
yeah, once we are
um,
getting the model.
many whatever publications are there, very
Mhm.
few are there with the results of Q8.
Okay.
And
If we are getting better results with Q3, then it we will be satisfied that okay, the models are working
mm,
fine. We can also
mm,
consider Q8 along with
yes,
it.
okay.
Some add some
And
additional
then there
packages.
is one parameter, SOV is also there, so
Yes, yes, right.
overlap. So that parameter is also there in many papers
Okay,
with Q3.
okay, okay. Okay, I will try to include that as well,
Mm,
and then we'll execute it.
yes.
Okay, sure. So I will update you accordingly.
Okay. Yes. Okay.
And there are other data set also, like we have, let me share you one paper in the meeting comment. Just a minute. Because there are other data sets given apart from CASPs. So you see how they are, if we can, Cameo and Cargo data set is there. Mm, if you go in
Mm,
other major data set section, so
mhm.
Astral 14, Cameo, Paroport 338, and then all CASP data. So for CASP also we have CASP 3, CASP 9, then we have other CASPs. And CB50
Mm,
513 is also mentioned here.
mhm. But I don't find link for that CB. Means
Okay.
raw data link. I'm not
Yeah,
able to find.
CB396 is there, RS125. Okay, I will try to get link from this publication. Maybe they have
Mm,
mentioned somewhere. So we'll try to check it. If once I'm getting it, I will share you link in the chatbot that we are having. Okay.
mhm. Here mentioned something that Cameo dataset is in reference 44.
Yeah. Yeah, so we need to go to that reference and maybe
Hmm.
we can get from there. So we'll
Yes.
try to check with these data set also, like to make it more
Hmm.
comprehensive if we are getting better results with the models.
Yes. Okay.
Okay, that's fine. Yeah, I think we can wrap up for as of now because we are done for the discussion. And Bhavani, are you there?
Yes, Ms.Swati.
Okay. Okay, so I think we have discussed so far and what needs to be executed for the next module.
Okay,
So maybe we need to have the next session in the
fine.
on the weekend. Yeah.
Okay, good. So far we are done with 4 modules, right?
Yeah.
Yeah. 3 modules have 2 sessions, 6 session, and earlier we had 1 session of module 1. It's 4 modules done so far.
Yes.
Yeah. And Swati have shared the feedback link in the chat. Please fill
Yes,
it
ma'am.
out and give your feedback of this module's feedback. Okay. Yeah.
Yes, ma'am.
Let me stop the recording first.